Okay, so we're looking at question 8 from the 2012 exam. So by introducing slack variables and artificial variables, and using the two-phase method, we aim to write down the first tableau of the simplex algorithm of the following LP problem down here, and we write our answers in the tableau provided. And finally, we have to circle the entry that we would pivot on. Okay, so firstly, I'll underline this, just as a reminder, as sometimes it's easy to forget after doing the bulk of the work filling in this tableau. Okay, so firstly, what we have to do is to get the constraints we're given in the appropriate form to pop into the table down the bottom. Okay, so the first condition we need to satisfy is that we need these numbers on the right hand side to be non-negative numbers. So in this case, we need to fix up the first constraint that we're given, and we do that by multiplying this inequality by -1. So that gives us minus x minus 2y minus 3z is less than or equal to, note the sign swap, 7. Okay, so we've satisfied that first condition, that we have non-negative numbers here. So now we aim to get less than or equal to signs and greater than or equal to signs into equal signs. And we do that by the introduction of slack variables and artificial variables. Okay, so let's do that now. So let's work on the first constraint. So we have minus x minus 2y minus 3z. And because we have a less than or equal to sign here, we introduce our first slack variable, which we'll call s1. And we need to add this slack variable to this side. And then we can change our sign into an equal sign and then write the number 7 because it's there. Okay, now for our second constraint, we have 4x minus 5y plus 6z. And because we have a greater than or equal to sign this time, we need both a slack variable and an artificial variable to help us get this sign into an equal sign. So how we do that is we give ourselves a slack variable, but notice that we give it a coefficient of -1 because we have the greater than or equal to sign here. But to counteract that and to make our constraints in canonical form, we add an artificial variable, which we'll call r, and that allows us to write an equal sign and then a number 8 at the end there. Okay, so we've got our constraints now. So the next step is to give ourselves a maximization problem, which will be the first phase of the two-phase method. Okay, so in this case, we aim to maximize the variable w, which we let be equal to minus r. And we do that because ultimately in this first stage, we aim to get rid of this artificial variable r by creating a maximization problem to make it equal to 0. And then we continue with our second phase, which is our maximization problem up the top there. Okay, so in this case, minus r is equal to 4x minus 5y plus 6z minus s2 minus 8. Okay, so we've got our maximization problem now, using these constraints up here. Okay, so we can quickly write in our variables, like so, and we're ready to start filling in the entries of our tableau. So firstly, the first row, we will correspond with the first constraint that we're given. So this first entry is -1, as that's the coefficient in front of x for the first constraint. Similarly, we have -2 for y, -3 for z, 1 for s1, 0s for these two as they don't make an appearance up here, and we have 7. Okay, and same for the second constraint. I'll do this a little bit quicker. Okay. Alrighty, now we're looking at the Q row. We're looking at filling that one in. So we look at our objective function up here, and we change the signs on the coefficients in front of here, as we do for all LP problems. So we have -3, 11, -4, and then 0 for the rest of the row. Okay, so I'm going to stop here for a second and have a look at what our basic variables are for this maximization problem up here. So up the top here we have S1. As we see, we have 1 and 0 in every other row. And for this row we have R being our basic variable. Okay, so I do that first because we notice that W is equal to minus R. So when we're completing the W row, it's simply the R row multiplied by minus 1. So every number you see in here will be multiplied by minus 1 in the W row. So we have minus 4, 5, minus 6, 0, 1, minus 1, and minus 8. Okay, great, we finished our tableau. And we finally remember what we underlined and exclamation marked up here. Okay, so to find our pivot entry that we have to circle, we find the most negative number in this W row, not including the value at the end, which is negative 6. And then we look at the corresponding ratios given by these two numbers and these two numbers, which in this case are 7 on minus 3 and 8 on 6. And then we find the ratio that's the least non-negative ratio. Now, as this is a negative ratio, this is the ratio we're after. So that means that our pivot entry will be this entry here, that's a 6. Okay, and that's all we have to do in this question.